Welcome everyone. Today we are going deep, really deep into Metro Bundler. So let's get started. You've typed npx React Native start dozens or maybe hundreds of times, but do you actually know what happens the moment you hit enter? Most developers don't. And that gap in knowledge, it's what makes the difference between a developer who just uses React Native and one who truly understands it. By the end of this video, you'll know exactly what Metro is doing under the hood. Every phase, every transformation, every decision it makes before a single line of your code runs on your phone. This is not beginner content, but I'll build it up from the ground so even if you're newer to React Native, you'll follow along. Let's get into it. So before we go further, let's make sure we're on the same page about what Metro actually is. Metro is React Native's dedicated JavaScript bundler. Now notice I said dedicated. Metro wasn't built to be a general purpose bundler like Webpack or Rollup. It was built specifically for mobile, for React Native's unique requirements. There are three things Metro is really optimized for. First, speed. Metro uses incremental builds and delta bundles, which means it only rebuilds what changed, not your whole app. Second, the module graph. Metro builds a complete picture of all your app's dependencies, every import, every require. Third, fast refresh. This is the magic that lets you save a file and see your change on your phone in under a second without losing app state. Now, let's look at how all of this actually works when you run that command. All right, here's the 30,000 foot view. When you run npx React Native start, Metro goes through exactly four phases, and understanding this pipeline is the key to understanding everything else. Phase 1 is initialization. Metro reads your config, sets up the resolver, and boots its HTTP server. Phase 2 is crawl. Metro walks your entire file system, builds a file map, and registers every JS and asset file it can find. Phase 3 is graph building. This is where Metro figures out how all your modules connect, starting from your entry point and following every import. Phase 4 is serve. When your app makes a bundle request, Metro transforms the files and assembles the final bundle. Here's the critical insight at the bottom there. Metro doesn't redo this from scratch every time you save a file. It only reruns the affected parts of the pipeline. That's what makes it feel instant. Let's go through each phase one by one. Phase 1 is initialization. This happens the moment you run the command, before Metro has even looked at a single file in your project. The first thing Metro does is load your metro.config.js file. If you don't have one, it falls back to defaults, but it always merges your overrides on top. This is where you configure things like custom resolver extensions, transformer plugins, and module blacklists. Then Metro calls resolve config internally, which locks in all the resolver rules. This tells Metro things like when it sees an import for a .ts file, which transformer should handle it. When it encounters a platform-specific file like .ios, .js, which one wins. Finally, Metro boots its HTTP server, binding to port 8081 by default. This is the server your app's JS engine will talk to when requesting the bundle. One important thing, this initialization step is fast. It's mostly reading config and setting up data structures. The heavy lifting starts in phase 2. Phase 2 is where Metro earns its reputation for speed, the file system crawl. Metro needs to know about every single file in your project before it can resolve any imports. To do this efficiently, it uses Watchman, Facebook's open source file watching daemon. Watchman uses native operating system file events, which means it doesn't have to scan directories. It just gets notified when something changes. And crucially, it caches its state between runs. So the second time you start Metro, it already knows most of the file system and only processes what changed. If Watchman isn't installed, Metro falls back to Node's built-in file system module. This works everywhere, but is significantly slower on large projects because it has to walk the whole directory tree from scratch every time. The output of this phase is something called the Haste Map. Think of it as Metro's internal phone book. It's a giant lookup table that maps every module name and file path to its metadata, location on disk, file type, target platform, and a hash of its contents. That hash is important. It's how Metro knows whether a file has actually changed and needs to be retransformed. Now we get to the most intellectually interesting part: dependency resolution and graph building. Metro starts from your entry point, usually index.js, and asks, what does this file import? It finds app.js. Then it asks, what does app.js import? It finds navigation, your screens, maybe some utilities, and it keeps following that chain all the way down until it hits every leaf node, every file that doesn't import anything else. The result is a directed acyclic graph, or DAG, where each node is a module and each edge is an import relationship. This graph is everything. It tells Metro exactly what files need to be in your bundle, in what order, and which ones can be processed in parallel. Here's a key insight. Metro resolves platform-specific files at this stage. If you have homescreen.ios.js and homescreen.android.js, Metro picks the right one based on the platform flag you're building for. Node modules are also part of this graph. They get the same treatment as your own code. Metro traces through every import all the way into node_modules. This is why a bad transitive dependency can slow down your build. Here's where the real magic happens: the transformation pipeline. Every single file in your dependency graph goes through this exact chain. Let's walk it step by step. It starts as a source file, your raw.js, ts, or tsx. Metro hands it to Babel, which strips out all the React Native specific syntax, converts JSX to regular JS function calls, and applies any syntax transforms you've configured. This is where your modern JavaScript gets turned into something the JS engine can actually run. Next is inline requires. This is a Metro-specific optimization. Instead of eagerly loading all modules at startup, Metro rewrites your imports to only load a module the first time it's actually used. This makes your app's initial boot noticeably faster. Then, in production mode, your code goes through a minifier, typically tersor, which strips white space, shortens variable names, and removes dead code. Finally, if you're using Hermes, which is the default JS engine in React Native these days, Metro can optionally compile your JS to Hermes bytecode ahead of time. This means the engine skips parsing entirely at runtime. The key performance insight: Metro runs these transformations on worker threads, one per CPU core, and every transformed output is cached by file hash. So on your next run, unchanged files skip the whole pipeline entirely. Now let's follow a real request end to end. Your React Native app boots up, the native bridge starts, and the JS engine fires off an HTTP GET request to localhost 8081/index.bundle with query params telling Metro which platform and dev mode you're targeting. Metro's HTTP server receives that request and checks, do I already have this bundle graph in memory? If yes, it can skip straight to serialization. If not, it calls into the graph processor to resolve the full dependency tree starting from your index.js entry point. The graph processor walks the dependency graph we talked about earlier, and for each module that hasn't been transformed yet, or whose cached transform is stale, it hands the file off to the transform worker pool. The workers run Babel, apply optimizations, and send back the transformed module code. The graph processor assembles all of these transformed modules, and Metro's serializer combines them into a single bundle, adding the module system runtime, the require polyfill, and all your app code in the correct dependency order. That final bundle gets streamed back as an HTTP response, your JS engine evaluates it, and your app is running. The whole thing on a warm cache can be under 200 milliseconds. Fast refresh is one of the most impressive engineering achievements in React Native, and Metro is at the heart of it. Here's the loop. You save a file. Watchman, which has been watching your file system this whole time, fires an event instantly. Metro receives that event, checks which file changed, and retransforms only that file using the cached graph it already built. Here's the clever part. Metro doesn't just resend the entire bundle. It computes a delta, essentially a diff, of only the modules that changed. Then it pushes that delta over a WebSocket connection to your running app. Your device receives the patch, the Metro runtime on the device applies it, replacing the old module with the new one. React's reconciler takes over from there. Because fast refresh understands React's component model, it can re-render only the affected components while preserving state. So if you're filling out a form and you fix a style bug in the button, your form data doesn't disappear. The whole cycle, save to visible change on device, typically takes under 500 milliseconds on a warm setup. That's what makes React Native development feel so productive. And that's Metro Bundler, from command to bundle fully demystified. Let's recap the four phases one more time. Init loads your config and boots the server. Crawl builds the haste map with Watchman. Graph resolution traces every import in your app. And the transformation pipeline converts, optimizes, and caches every module before it hits your device. Now let me leave you with three power user tips. Number one, the reset cache flag. When Metro starts acting weird, wrong transforms, stale modules, mysterious errors, just run Metro start with the reset cache flag. It nukes Metro's transform cache and starts fresh. It's the first thing you should try before anything else. Number two, custom resolvers. In your metro.config.js, you can set resolver.extra node modules to a map of module name aliases. This is incredibly useful in monorepos where you want to point imports at local packages instead of installed ones. Number three, blockList. If Metro is slow to start, check whether it's crawling directories it doesn't need, like documentation folders, large binary assets, or other packages in a monorepo. The resolver.blocklist config accepts a regular expression and tells Metro to skip those paths entirely during the crawl phase. That's it for today. If you found this useful, like this video and subscribe to this channel for more deep dives like this. I'll see you in the next one.